Alright, for this one we're going to construct a truth table for the given statement. And the given statement will be read as the quantity, that would be this right here, Q or P, and this is going to be an and this will be the quantity not P or not Q. So let's write that down. We're going to have Q or P and not P or not Q. So let's start off by establishing a truth table. Alright, first one we'll do will be P, and then we'll do Q, and I'm going to do those simultaneously. So P could be true, and Q could also be true. P could be true, and Q could also be false. Which brings us to the fact that P might be false, but Q could be true. And additionally, if P is false, that means Q could also be false. So I've established the truth quantities for P and Q here. And now we're going to go ahead and understand that since we have a not P right here and a not Q right here, we need to establish those values also. So we'll have not P and we'll have not Q. So starting off with the fact that P is going to be true, that means not P is false. If P is true, not P is false. Once again, if P is false, not P is true, and if not P is false, not P will be true. Do the same thing for Q. Q is going to be true, that means not Q will be false. If Q is false, that means not Q will be true. If Q is true, then not Q will be false. And if Q is false, then not Q will be true. So now I've got the four values that I'm going to need: P, Q, not P, and not Q. The next one we're going to do is go ahead and look at this particular statement. We will look at the P and Q first. So this one's going to be, or I should say Q or P. So we'll write that down as Q or P. Now in order for this to work, either Q or P or both will have to be true. So we start right here and we look at P and Q. Q is true, P is true, therefore this is true. In this case, Q is false, but P is true, so this will be true. Q is true, P is false, this will be true. And then we have both of them being false, so then this statement will be false. Alright, then we're going to look at this particular problem, or I should say part of the problem, which is going to be not P or not Q. So once again, one or both of these expressions will have to be true in order for the whole expression to be true. So we have not P or not Q. So here's not P and or not Q. They're both false, so this is going to be false. Here this is false and this is true, so this will be a true statement. This is true, this is false, so this will be a true statement. And both of these are in fact true, so this will be a true statement. And then I can go ahead and put this all together. I'm going to have Q or P, and I've already established the truth values of that statement. Then we will have and not P and not Q, or I should say not P or not Q, which means that in order for this to be a true statement, they both must be true. In other words, this statement must be true and this statement must be true. So let's start and look at Q or P. This is true. And let's look at not P or not Q. and this is false, so then that will be false. Alright, continuing, we'll look at the statement Q and P right here, which is going to be, Q or P, which is true, and this not P or not Q is true, and since both of them are true, this entire statement will be true. Once again, this is true and this is true, therefore the entire statement will be true. However, here the Q or P is false, even though the not P or not Q is true, so that means the entire statement will also be false. And that would be the truth value for our truth table for this particular statement.